This is Pet Life Radio. Let's talk pets.
Welcome to Aquariumania on Pet Life Radio. I'm your host, Dr. Roy Anong, speaking to you from the University of Florida's Tropical Aquaculture Laboratory. Thanks for joining us. Many hobbyists know that clownfish and a few other marine species are now bred by fish farms for the industry. However, most other marine aquarium fish are even more difficult to breed and are available only as wild-caught specimens. How can we ever crack their breeding and culture codes? Rising Tide Conservation, an initiative spearheaded by the SeaWorld and Busch Gardens Conservation Fund, is a collaborative effort designed to advance methods and disseminate information regarding captive breeding of marine fishes and to provide alternatives to collection. Eric Cassiano and Matt Wittenrich, two scientists based at the University of Florida's Tropical Aquaculture Laboratory and members of the initiative, have been concentrating their efforts on culture methods of a variety of species, including anthias, tangs, dragonets, and porkfish. Join us as we discuss the opportunities and challenges in their work with Rising Tide Conservation. We'll be right back with Eric and Matt after these messages.
It's designerpetsweaters.com. Hand-knitted designer sweaters for your precious pup or cool cat. Beautiful couture patterns for your pets, including custom-knitted formal wear, casual wear, yachting, and even sports-themed. Many designer pet sweaters include feathered tammy hats, top hats, and a lot of sparkle. Each sweater includes leg loops, front paw sleeves, and leash opening. Visit designerpetsweaters.com to order your four-legged fashions today. Your pets will stay warm for the winter and be runway ready. Large or small, we fit them all. designerpetsweaters.com.
Let's Talk Pets on PetLifeRadio.com.
Welcome back to Aquariumania on Pet Life Radio. My guests today are Eric Cassiano and Matt Wittenrich, aquaculture research scientists based at the University of Florida's Tropical Aquaculture Laboratory. Hi, Eric and Matt. Thanks for joining us today.
Hello, Roy. Hello, Dr. Roy. Thanks so much for having us.
So you guys have been involved in some really interesting work, and we're going to kind of get into that in a second. But let me start with you, Eric. Can you tell us briefly how you ended up working on marine aquarium fish culture and live feeds after having worked originally with oysters?
Yeah, right. I started out working with oysters at OSU and then working with clams at UF. And then my master's thesis focused on evaluating Florida pompano larvae that had been fed noctilucalinoid copepods Pseudodapnus pelagicus. And why that actually is important for marine ornamental fish is a lot of the larval phase of a lot of these marine ornamental fish species require a copepod as a first feed or some sort of marine zooplankton as a first feed other than what is typically used in larviculture currently, which is rotifers and Artemia. So that's sort of why I got hired. That's why Craig sort of looked me up and hired me. And
Craig's the director of the lab, of course. But copepods, right. What can you tell us when you say copepods? Some folks may not be familiar with what a copepod is.
Right, copepods. They're one of the most ubiquitous marine organisms in the zooplankton. So a lot of these fish species, ornamental or otherwise, when they're in their larval form, they're exposed to that as a prey item when they first begin feeding. Copepods are found in literally any speck of water that you find, freshwater or marine. So like I said, they're pretty ubiquitous. They're pretty everywhere, and they're quite varied in morphology and form. So they're actually a good species to grow for that first feeding phase. But they're quite different from species to species and group to group.
Okay, so now, Matt, I know some of our listeners may have heard your Aquariumania podcast when you talked to us about breeding mandarin gobies. For those that haven't, can you give us some highlights of your PhD work and how this fit in with the work you're doing now?
Sure, yeah. I've been involved with marine ornamental aquaculture for quite some time. I think originally I started breeding fish when I was about 15, and that led ultimately to a PhD program in actually functional morphology. And this actually carries over with what Eric was talking about the copepod. So basically what I did for my PhD research was trying to figure out the morphological attributes of these larvae that make them either successful or not successful at capturing prey. For copepods, for example, there's over 14,000 species of copepods, and all these larval fish, they're actually highly selective in what they choose. So my work basically focused on what drives that selectivity and how these larvae are basically different as they develop, and how selectivity works, and how we can sort of recreate that in captivity to overcome some of these hurdles.
And I guess maybe just to bring it back a little bit in case some folks aren't familiar with, when you say larvae, how old and how big are marine larvae?
Marine larvae, they vary in size. They're quite considerable differences. But a larva, as soon as an embryo hatches from an egg, it's called a larva. But some of the fish we work with, they're as small as 1 millimeter. One of the more recent successes we've had is the lancer dragonet, and they actually start feeding at 1.09 millimeters, and they hatch, actually considered a larva, at under a millimeter. The average marine fish hatches out probably 2.5, 3 millimeters long and initiates feeding around that size. But to throw it in comparison even more, a newly hatched clownfish larva is about 4 millimeters, and that's sort of the industry standard of what we're used to rearing, and hobbyists should be familiar with that as well. But there's a considerable size range for what's considered a larva. So
that's kind of the trick. These are really tiny fish, and you've got to find really tiny prey items or basically live foods that they're going to eat then, right?
Absolutely. Tiny fish and tiny, tiny prey.
So you guys are both working here at the Tropical Aquaculture Lab. Are you guys getting along, or are there any fights at all?
Well, our doors are closed to each other right now.
Yeah, I think Eric and I, we complement each other very good. Eric is a live food expert. He's really good at culturing these things. So if you can figure out what they eat and how to culture them, I think together we're capable of doing some pretty awesome things. So I'm really happy to be working with Eric.
Oh, me too, Matt.
That's good. I hear the love. That's great. Can you give us a little history of the Tropical Aquaculture Lab, I guess, and how this ties in, how its work is tied in with marine aquarium fish reproduction?
Yeah, the University of Florida, it's really an amazing thing. It has an amazing history in the freshwater ornamental aquaculture. It was started in I think around 1996 by Craig Watson, and it quickly amassed an incredible team of reproductive biologists, aquatic vets, and extension personnel. Florida is one of the biggest producers of freshwater fish for the aquarium industry in the country. And this lab really helps drive the industry. It helps come up with some breeding techniques. It helps the farmers arrange some of the import-export permits and just some of their overall problems. So it's a really good place to start the Marine Ornamental Aquaculture Lab. The infrastructure and the talent are already in place. So I'm really excited to be part of the team. But one of the greatest things, too, is in 1976, this is really the birthplace of Marine Ornamental Aquaculture in the country. Martin Moe and Frank Hoff started breeding clownfish commercially over in St. Petersburg. So it's kind of neat to be back in that feeling, that area.
So let's get to Rising Tide Conservation now. Can you tell us a little more about Rising Tide Conservation, the initiative, and what it's all about?
Yeah, sure. Rising Tide, the conservation initiative, was started by SeaWorld Busch Gardens, and it's headed up by Dr. Judy St. Ledger of SeaWorld. And it consists of numerous research facilities, industry partners, and AZA institutions that are all dedicated to solving problems associated with marine ornamental fish production, and specifically those surrounding pelagic spawning species, which is tended to be the bottleneck in marine ornamental fish production. So it's basically forming this cohesive group of individuals with different areas of expertise that can approach problem solving collectively. And it's worth mentioning that the initial funding for a lot of these projects has been provided by SeaWorld Busch Gardens, USDA, Shed Aquarium, Petco, and AZA itself.
Can you tell folks what AZA is in case they're not familiar with AZA?
Yeah, sorry. AZA is the Association of Zoos and Aquariums. So a lot of these, like Florida Aquarium, Georgia Aquarium, they're all part of this large association.
You mentioned, so it sounds like a really big group of folks.
Yeah, about 80 individuals, 47 institutions, along that line, something like that.
So what is the role for each of the major groups of collaborators?
Well, for instance, it really just depends. So for our role will be to research that's aimed at answering some of these problems, like marine ornamental fish production. At the first Rising Tide meeting, we identified 5 species that we decided to focus upon as a part of this initial start. So and those 5 species were yellow tang, Pacific blue tang, bang-eyed cardinalfish, emperor angelfish, and Bartlett's anthias. And these species were chosen because they're highly prized in the aquarium trade, and they all have some sort of sustainability issue associated with them. Another reason why these species were picked was because unlocking the keys to the production of one species will likely lead to the production of numerous species in their respective groups. So, for example, production protocols for Bartlett's anthias should open the door for other anthias species as well. And some of these aquariums, they harbor these species within their exhibits. And so that's a huge advantage for a research facility like ourselves, that we don't have to dedicate time and energy and labor to maintaining broodstock when the established populations are already available. And then, of course, industry partners help put that product available for other AZA institutions and also at the hobbyist level for consumers.
So you've got scientists, you've got AZA institutions, the public aquarium, many people visit every year, and then you've got the commercial producers. So it sounds like a really great group of folks to kind of push this forward. So you mentioned the public aquaria. How are they actually, I guess, helping with this, specifically? You mentioned they've got different types of fish that you may be interested in, others that are, I assume, spawning in their tanks, or what's going on with all that?
Right. The initial project for Rising Tide is funded through the AZA's Conservation Endowment Fund grant. So we've targeted aquarium exhibits at 8 different AZA institutions around the country. And those institutions are Columbus Zoo, Florida Aquarium, Georgia Aquarium, Henry Dorley Zoo, SeaWorld Shed, and Steinhardt, and Virginia Aquarium. And they all contain these candidate species within their exhibits. So then we try to collect these eggs from the exhibits, ship them to the Tropical Aquaculture Lab, and run experimental trials which are focused on obtaining information to help us better understand their embryology and larval development. And one of the biggest advantages of this project is that these exhibits routinely house 100 or plus species. So, not only are we getting eggs from these candidate species, which I just listed, but also eggs of other species as well. And many of these species we've never been examined before, so it's a huge advantage for us as a research facility and the whole group as a whole. How
are you guys collecting these? How does that work?
We've developed a really simple floating egg collector. Basically just modified a plastic tub that is designed to skim the surface of the water. So it just floats and it skims the surface of the water and concentrating the eggs inside of the tub. It's using basic, simple airlift technology. And it just floats right in the exhibit itself, either at night or in the morning whenever these fish are spawning, whenever the aquarist identifies that the fish are spawning. And it's worked relatively well, surprisingly so.
So I guess the eggs are floating up to the top, and these things get into the basket somehow, is what you're saying?
Yeah.
What species have you both been getting from these different AZA institutions?
I actually compiled a list here of the species that we've identified that we have been getting. I'll name them off: green chromis, sea bream, pajama cardinalfish, sergeant majors, leaf scorpionfish, seaweed blenny, bar gobies, yellow tangs, blue tangs, orange shoulder surgeonfish, batfish, and several species of grunts.
So that's a pretty wide list of species. Have you guys had any successes with any of those in terms of getting them beyond, the egg stage?
Right. So for me, the simple fact that we're able to collect these eggs at all is a success. I mean, isolating tens of thousands of 1 millimeter diameter eggs from 10,000 plus gallon exhibits, packing them and shipping them to the Tropical Aquaculture Lab and having them hatch successfully is definitely a success of the project. And although proper protocols are still being established, the fact that it worked really bodes well for future endeavors with these aquarium partners. And also identifying them once we get them as eggs. I know most of your listeners may not know, but most marine fish eggs they look very similar, so it's very tricky to identify them, especially to the species level, when they're at that stage. So we partnered with Tom Walker at the University of Florida, as well as Lee Wake from Smithsonian Institute, and we're developing molecular techniques to help with this identification process. So as far as the larval rearing is concerned, we've had various levels of success there as well. We've gotten some first feeding blue tangs, which you'll recall is one of the target species that we mentioned earlier. We've gotten green chromis to approximately 20 days post-hatch. We've successfully reared Monodactylus argentis, or moonfish. We've successfully reared and returned back to their respective aquariums sea bream, French grunt, and porkfish. And we've conducted experiments identifying an appropriate early feeding protocol for porkfish. And commercial producers are, as we speak, growing them from eggs provided by SeaWorld. So that partnership between the commercial producers and an AZA institution is as well a success for the project.
Well, that's great. I actually want to go into a little bit more detail with some of those successes that you've had in our second half. But why don't we take a break, and we'll continue our discussions with Eric and Matt after these messages from our sponsors.
Hi, I'm Dana Humphrey, the founder of Whitegate PR. We have been specializing in PR and marketing in the pet industry for over 10 years. If you have a pet product or service you would like to promote, give us a call. We can help create awareness for your brand on TV, radio, magazines, newspapers, and blogs. Feel free to reach me directly at 619-414-9307 or learn more on our website at whitegatepr.com or follow us on Facebook.
Let's talk pets
Let's talk pets
on Pet Life Radio.
Pet Life Radio.
PetLifeRadio.com.
We're back and continuing our conversation with my guests, Eric Cassiano and Matt Wittenrich, aquaculture scientists working at the University of Florida's Tropical Aquaculture Laboratory with marine aquarium species reproduction and culture. So, Eric, you talked quite a bit about some of the kind of the background of Rising Tide. Matt, you talked a little bit about the history of the Tropical Aquaculture Lab and how it all kind of fits in. Let's talk a little bit about some of the details, what makes all of this really difficult, and how you guys are setting up the work you're doing to try to further the culture of a lot of these really tricky species. I guess maybe we'll start with some of the dragonets and the gobies. You want to talk a little bit about some of the work you're doing with these, Matt, and also I guess for the listeners who maybe aren't familiar with this group, kind of give them a little summary again of what a dragonet is and some of the common species they may be familiar with actually as dragonets.
Right, yeah, absolutely. If I can back up just a little bit further, too, I just wanted to give a little bit of a history or not really a history, but talk about why Rising Tide is so important. But historically, the marine ornamental aquaculture industry, or sort of advances that have taken place, have sort of taken place behind closed doors. The commercial guys, if they figured out how to raise a clownfish or a bangeye cardinalfish or a dottyback, it was going to make them money, and they didn't really want to talk about it. So there hasn't been really anyone doing the research or showing people how to do this, or anyone really advancing the field. And that's what Rising Tide, really, this is the largest sort of initiative with a lot of people that are talking, that are getting involved, and really sharing ideas. And this, in my opinion, is really what's going to advance and kind of come up with the next leaps and bounds forward so we can raise these anthias and angelfish. So ultimately, we have these 5 target species, and these are our top tier. This is ultimately what we're trying to get to. But in the meantime, we're using model pelagic spawners. And for me, one of my favorite model groups is the dragonets. I've gotten a lot of experience with the group over the last few years. So for me, it's just a great model to answer some of these detailed questions about incubation, development, and just some of these overall ideas that affect survival. But what we've been working with lately, the lancer dragonet, and this is a local species that is extremely rare in the trade. But some of the more popular species would be the mandarin, the psychedelic mandarin, they call them, the spotted mandarin. And these are just sort of really colorful fish that hop along on the bottom. They're commonly called blennies or gobies, but in reality, they actually make up a family all of their own, the dragonets. So we succeeded with the lancer dragonet, and to me, this is a huge model species. They have some of the smallest eggs we've seen in the lab. So the eggs, they're pelagic eggs, and they come out around 500 microns, so just a tiny, tiny egg. And this, to my knowledge, I think it represents one of the smallest first-feeding larvae ever recorded as well, at about 1.09 millimeters. So trying to feed something that small really was a challenge. But the way that we do this, we kind of come up with a structured regime of what we do. And we do this with all the species, and in reality, it's a proven technique that we can use to kind of figure out what they eat and how to raise them. But we offer them kind of a slew of wild plankton, everything that they would be exposed to in the wild. We let them feed for a set amount of time, and then we actually take them out and see what they ate. We see what's in their gut. So we actually have to do really, really tiny dissections to see what these fish ate. And in the end, we have talented guys like Eric identifying these zooplankton organisms and culturing them and trying to come up with these commercial protocols. But the lancer dragonet was a huge success. These guys are just absolutely tiny, have a lot of bottlenecks through larval development. And they also have almost a 60-day pelagic larval phase, which is a really long time for a fish to stay up in the water column. So most of the fish that we're dealing with, they're pelagic spawners. So they release these tiny buoyant eggs that float around in the open ocean for about 3 weeks usually, and then they settle back to the benthic habitat or the coral reef where the adults are found. So a 60-day pelagic phase is a really long time. So we were successful with the lancer dragonet, and then most recently we started playing around with the ocellated dragonet. And if you listen to the last podcast of mine, we talked about the mandarins, the green mandarin and the spotted mandarin. And these are 2 species that there is a commercial protocol in place. Oceans, Reefs, and Aquariums, the marine fish hatchery over in Fort Pierce, is successfully raising these fish and offering them to the trade. But the ocellated dragonets, commonly called scooter blennies and red scooter blennies, they reproduce in a similar fashion, but they do have bottlenecks through larval development. The first feeding larvae are a little bit smaller, and they're highly selective. So we were able to kind of identify what those larvae were eating, and we're working on culturing that organism now and trying to get another commercial protocol in place. So pretty good successes so far.
Now, you mentioned wild zooplankton. Can you kind of describe for the folks listening how you're actually getting these zooplankton, these, again, real small organisms that these guys are eating?
Yeah, definitely. Wild zooplankton, it encompasses a wide variety of organisms. There's probably over 1,000 different species that we're talking about. But generally, Eric talked about copepods earlier, and they are usually the dominant planktonic organism. But there's all kinds of things, ciliates, microzooplankton, and there's all kinds of things in that plankton. But what we do is we basically take a glorified pantyhose, or we take a plankton net, and we tow it through the water, and we sieve it out, and we try to concentrate the organisms that we do want to use as food, and we try to get rid of the nasty guys that are going to eat the larvae or bloom up in the tank and kind of pollute the water. We go back to Mother Nature. I mean, ultimately, Mother Nature has the protocol available for us out there. We just have to learn how to tap into it and understand how these things are surviving and what they're eating in the wild.
And you mentioned pantyhose, so do you use a lot of Eric's pantyhose, or are you actually...
We do. Eric has a good supply in his desk over there.
Yeah,
okay, good.
Mine are mostly fish nets, so it's be a little too large.
They're probably too big. That's true. Eric, you mentioned porkfish, and I know there was a whole process involved, from the SeaWorld to you guys being able to actually get them to a really good size. Can you kind of go into some detail as to how within the rising tide kind of framework that all occurred?
Yeah, the good people over at SeaWorld were collecting eggs from one of their exhibits, and they would ship them to us. We raised them up. We identified what was going to be the appropriate larviculture protocol or the appropriate first feeding regime. And as it turns out, this species actually lends itself well to being fed rotifers. So this is wonderful for commercial production and some of those industry partners that are part of Rising Tide, because they already have in place rotifer culture protocols and using artemia, which is what porkfish actually did well on as opposed to being fed copepods. So those protocols were already in place. So to take a fish like that and make it available to a commercial producer is much more attractive than trying to revamp their whole live feeds regime altogether. And it really shows that this is possible. It is possible for us to harvest eggs from an AZA institution like SeaWorld and grow them up and actually give them back to SeaWorld, some level of sustainability for the aquariums to display there.
So that's great. So they don't have to necessarily go back and collect more if they can continue to harvest, have them kind of raised up and then return to the facility.
Right, true. And perhaps, University of Florida can't speak for this, but perhaps there could be some sort of a contractual agreement between an aquarium and a commercial producer where the eggs are shipped to the commercial producer and then, they get first choice of the fish that they want and the rest can be sold back into the marketplace. But that's beyond the realm of the University of Florida, so. But ideally, that is a level of sustainability that's not been seen before within these AZA institutions. So that's encouraging, very encouraging, and a success.
Now, you mentioned also tangs. Either Eric or Matt, if you guys want to discuss a little bit. I know, I believe you mentioned in the initial kind of list of 5 yellow tangs and Pacific blue tangs as being of interest. Can you kind of remind us why those are of interest for this project, and then also some of the early work or preliminary work you have with those two?
The tangs are just hugely popular, heavily traded fishes in the marketplace. And almost daily now it seems that Hawaii, and especially the yellow tang is just a hugely iconic fish in the marine aquarium trade. Bright yellow, just a gorgeous fish. And it seems every pet store out there has one. And there's a lot of threats coming in from Hawaii about banning the aquarium industry and the collection of wild tangs from there. There's been some evidence that shows that the populations are declining. A lot of these organizations are blaming the aquarium industry, but inevitably it's many interconnected factors, pollution, climate change, you name it. There's a number of reasons, but the Gold Coast is no longer, let's say, extremely gold. So there's been a number of people in research institutes that are realizing that breeding yellow tang would just be a huge model species, and not only for, kind of returning the gold to the Gold Coast, but to really, as a research organism, if we can unlock the secret to the yellow tang, then inevitably we would unlock the secrets for innumerable species of pelagic spawning fishes, the butterfly fish, the angelfish, the tangs, you name it. But Charles Lately from the Oceanic Institute, he's been working for about 10 years on the yellow tang, and he's made some tremendous advances with it. So we're hoping to follow in his footsteps and hopefully come up with some other keys working with him.
Have you done some work with the blue tangs also? I heard some mention of that.
Yeah, I'm actually really excited. So we've been working with the Columbus Zoo, and we've been getting some viable samples. We actually sent out some eggs for DNA from Tom Walsick from the University of Florida, and he gave us some pretty interesting results. He said that we've been working with Pacific blue tangs and also orange shoulder tangs. At the time, we didn't know necessarily what we were working with, but we were excited that we actually had larvae in the tanks, and they were successfully feeding. We have some microscope shots of some blue tangs that are just chock full of copepods in their gut. So it definitely was encouraging. We didn't bring them too far. I think we got them to maybe 10 days, but it is a huge step in the right direction, so we're getting there.
That sounds great. Now, I know you two have also been working on Bartlett's anthias. Can you maybe talk a little bit about what the anthias fish are for folks that aren't familiar with that group, and then some of the work that you've done so far with them?
Yep, I'm going to field this one to Eric. Those are Eric's babies.
Oh, sorry. Yeah, anthias are a group of serranids, so they're in that grouper family. They're I would say highly valuable within that marine ornamental trade, and they're a pretty diverse group, and they're gaining in popularity. They too also produce a very small pelagic larvae. I believe they were right at 2 millimeters when they're ready to eat, something like that, or 1.8. Not as quite as small as dragonets. So, but what we're having the issue with the anthias for us is more of a broodstock issue where we're having trouble getting those eggs to hatch. So we're getting them to produce eggs, and then we seem to have some high level of fertilization, like 85%, but the eggs are just not hatching. So whether it's a water quality issue or something along that line, we're trying to tease that apart. But that sort of also sheds a light on the other issues. It's not just always a live feed issue or getting them to eat or just an environmental issue. There's also water quality as well. It's hard for us to have to replicate what goes on in the wild in such a controlled environment. But they are pretty valuable fish. I don't know what they go for on the market, but they're very beautiful. And then we have high hopes that we're going to be able to rear them once we solve this water chemistry issue, which is what we think it is.
So you mentioned that you're breeding them. So you guys actually have a number of broodstock as well at the laboratory. And you guys you can maybe discuss that. Sure.
We have about 100 or so. I forgot the number. We've been doing some broodstock experiments. We had them in an experimental system where we had them in pairs and harems, and we were getting some egg production out of them. But overall, they seem to do better in a large group and let that social hierarchy just dictate who's going to spawn and who's not going to spawn. And that just seems to be how they do best. And then out in those natural sunlight conditions, we also had them indoors. So we've conducted experiments trying to determine if it was if we can put them in harems or pairs or if they can grow in aquariums or tanks. And we're still working on that data, but they really just seem to do well in a large tank in a big group, and again, just let them dictate their social hierarchy. And so we've got them back outside, and they spawn on a daily basis. Every day at sunset, we're getting 2,000 to 3,000 eggs from a group of 20. So we're pretty confident, and to be able to have that number of eggs every day. In our minds, it's only a matter of time until we're able to solve the problem and then get this fish eating. We did get them eating prior to the broodstock experiment, but now we can't even get a larvae to first feed. So we're fairly confident once we can get them to hatch again, but with significant numbers and live to first feeding, that we're going to be able to rear some. And that in itself is just going to open the floodgates for all of that group of anthias. And hopefully it'll be commercially viable, and these commercial producers will want to be able to repeat what we've done for production purposes.
The anthias, these micro groupers, they're kind of tricky in other regards as well. Can you tell us a little bit about some of the sex challenges that you've had with them?
Right, and we still, I hate to say anything because we don't really have any data to back it up, but they're protactous hermaphrodites, so they start as females and then they go to males. And we're still trying to tease that apart. We had a real problem with we ended up with a lot of males, let's just say that, with keeping them in female, in that female state. They ended up, even in a harem of 5 where we would have 1 male and 4 females, it just seems like we would end up with 2 or 3 males after a month or 2. Now, whether they actually changed from female to male or whether they were just juveniles as females and then they just grew up into a male, we're not able to tease that apart. But it did seem to end up as a male-dominant population, which is fine because all we need is a couple of females. But as far as running those broodstock experiments, it was very problematic in the beginning.
So that sounds like another big challenge. I think from what I understand, a lot of the marine aquarium fish really do have this kind of sex change capability, and makes that even another hurdle that you've got to kind of deal with, I guess, right? Yeah, most of the time, sex change is actually advantageous. In the case of clownfish, all you have to do is buy 2, and when they grow up, they form a heterosexual spawning pair. In the case of the anthias, it's actually really interesting. And we have learned a lot with the anthias. But even though there are so many males out there, it seems like there's only a few that are sexually mature and actually functioning as reproductive males. So like Eric said, he gave a great explanation of what's happening back there. But it's really exciting just how much we're actually learning in a short time frame here. I know this has just been a lot of preliminary work, although you guys have made some incredibly great strides with your collaborators and all the partners involved with the Rising Tide Conservation Initiative. I understand you guys are also building additional facilities. Can you maybe mention some of that and where you hope to go with it? Yeah, definitely. We're building a whole new greenhouse in the back. I'm not sure how many square feet it is. But right now, our saltwater space is kind of spread out among a few different buildings. So hopefully in the next couple of months, we're going to get an entire new greenhouse dedicated to the marine ornamental production. And I think once that happens, we're going to make some pretty big advances in a lot of different things. So we're really excited to have that happen. So Eric and I have been out playing in the dirt, making concrete. And so we're looking forward to that. Yeah, it's been a lot of fun, and it gives us an opportunity to really build from the ground up, literally, but to also just implement ideas that we want to accomplish. And also, to keep focused as to what, U.S. goal is as a land-grant university is to make this possible for commercial industry and for the public. And so, and to not get too carried away with trying to do something that's impossible to do, but make it possible. So yeah, it's very exciting. It's been a lot of construction, not just the greenhouse, but also inside the hatchery, making the live feeds facilities, and it's been a lot of construction, a lot of as they call it, Legos for adults. It's real fun. I had a good time doing it. So. And I also almost forgot to mention you've been doing a lot of experiments at home as well. You just had a baby, didn't you, Eric, recently? I did have a baby. I had it's my second one, so third one, and I'll have replicates. Well, congratulations on the new baby and the new addition to your family. Thank you very much. Well, unfortunately, we are out of time. I want to thank very much our guests Eric Cassiano and Matt Wittenrich and our producer Mark Winter for making the show possible. Eric and Matt, did you have any final words for our listeners? Just thank you, Roy, for doing this. It's a really neat thing. That's all I wanted to say. Thank you. Yeah, really, thank you, Roy. And I really wanted to thank all of our industry partners. Again, this is a hugely inspiring time to see so many dedicated people involved in this mission of kind of coming up with the next step in raising these marine ornamental fish. And I really see high hopes for the future, and I think we're gonna come up with some pretty big accomplishments soon. So thank you. I encourage all of you to visit my Aquariumania blog on Pet Life Radio. We'll be sure to put some pictures up of some of the species and different life stages and equipment that Eric and Matt have been using for their research. Also, if you have any questions, comments, or ideas for a show, email me at drroy@petliferadio.com. That's drroy@petliferadio.com. If you're ever in Florida, please be sure to visit the Aquariumania exhibit at the Florida Aquarium in Tampa. Until next time, please visit your local aquarium stores, buy more fish, and keep your tanks and fish healthy. And keep an eye out for new aquaculture marine fish species. They may be coming from the Rising Tide Conservation Initiative.
Let's Talk Pets, every week on demand, only on PetLifeRadio.com.